Okay, here's the video going over radical functions and piecewise functions. So this is the review for the test. I'm going to go through the odds. Here we go. So I already have the points plotted. We're going to get the points. You could either do this manually with an XY chart, plug in X's and get Y's. You want to plug in numbers that you're going to end up with perfect cubes. So for example, if you plug in 2 minus 2 makes that 0, and 0 minus 3 is negative 3. So you can plug in 2 and you get negative 3, which shows up right there on the graph. But most of you are relying on your graphing calculator, which is okay because we're that far now. But you go to math and 4, and that will give you the cube root. You plug it in and you use the table function of the calculator, and it will come up with the x's and y's that you want. Alright, so domain and range, from negative infinity to positive infinity for both of them, because if you think about it, this thing goes in all directions, to infinity and to negative infinity. So it goes to the right and left forever and ever, and it goes up and down forever and ever. Number 3, the biggest thing is that if you're using your calculator, you have to make sure that the x is the only thing that's in parentheses, because we only want the square root of x, then plus 4. And if you're good at translations of this, you know, the square root of x starts right here, but since I'm adding 4, it's going to move the whole thing up 4 units. It's going to look something like that. Now, unlike a cube root, a square root has a starting point. Okay, our starting point is the point 0, 4. Okay, and that tells us a lot, because in the x direction, when I'm looking at my domain, this is going to be my smallest x, and it looks like it's 0. Alright, x is equal to 0 at this point. Okay, and it's going to keep going all the way out, all the way to the right, forever and ever, to infinity. So it looks like my domain, square bracket, includes 0 all the way to infinity. My range, my y value at my starting point is 4, and then it's going to keep increasing upward to infinity. So my range is from 4 to infinity. Okay, number 5, again, I don't think we're going to have much trouble coming up with the x's to get the y's, but then again, you could always do this by hand. If you plug in negative 6 into this equation, think about this, negative 6 plus 6 is 0, 2 times 0 is obviously 0, so that's why we have a point at negative 6, 0, and so forth. So if you didn't have the graphing calculator, you could always type in x's and get your y's. Your domain, again, your starting point, this point right here, is negative 6, 0. So it looks like that's my smallest x. My biggest x would go all the way to positive infinity. Oops. My range, my smallest y, looks like it starts at 0, and it goes up to positive infinity. Okay, solving radical and cube root, square root and cube root equations. That's all we're really going to with this. So the radical is already by itself. Okay, so we can just go ahead and square both sides, because the opposite of a square root is squaring. So when I square a square root, I get the radicand, what's underneath, and it's that simple. Okay, and then I have to subtract 5, obviously. it looks like x equals 59. You can always check your work. 59 plus 5 is obviously 64, and the square root of 64 is 8, so it checks out. Now, one like this, you have to make sure you get the radical all by itself before you square. So I had you write that out in your notes with a big star by it, and a lot of you forgot to do that on the quiz. So I want to add 10 to both sides first, and then, that's an A, once the radical is all by itself, then I can go ahead and square. I have A plus 10 equals 81. All right, hopefully you can see this. I haven't been writing in marker. And then subtract 10. A equals 71. Again, plug it back in. 71 plus 10 minus 10. That's the square root of 81. Square root of 81 is 9. 9 minus 10 is -1. So I plugged it back in. It works. Number 11, I see this -2 out front, and I know this is -2 times the radical. So I have to divide both sides by -2 before I get started. Those two are going to cancel out. Now, you have to be careful here. A lot of people, when they go to rewrite what's left, they'll write it just like this. And what they're forgetting is the radical. This thing is still, you know, a radical 5 minus 5 end. So don't forget to rewrite that. So now I square, because the radical is by itself. It's going to cancel out over there. I have equals 25. So if you think about this, this has to be -4, but we can do the algebra. So you subtract 5 from both sides, you get 20. Divide both sides by -5, you get n equals -4. Number 13 is a cube root, and it has 3 out front, so I have to get rid of that by dividing by 3, because that's 3 times the cube root of 5n. So cancel that out. Still have a cube root, but now I have it equals 15. Then I have to cube both sides. A cube root gets canceled out by cubing it. So I just left with the radicand, and then 15 cubed, I think it's 3,000 some. Yes, 3,375. Divide by 5. You get 675. So you might not be, you might think that, oh, that answer is way too big or whatever, but if you plug it back in, I mean, I'm taking the cube root of something, so I'm going to need a pretty big number in there. So you plug it in, you can plug it in your calculator, just like this. Use the math. 5 times 675, close the parentheses, you get 45. So pretty easy check. Okay, this one, when I look at it, I have 2 6s that are along with my cube root. I have plus 6 and I have being multiplied by 6. So when you did something like this, you can kind of relate it to this. When you were solving this equation, you got rid of the 6 first and then divided. You always got rid of it at adding, subtracting first, and then multiplication and division. Same deal with this. So we're going to subtract 6 from both sides. In the rewriting part, don't forget your radical. Then I'm going to divide by 6. Those are going to cancel out. Still have my radical. 6 divided by 6 is 1. And then I have to cube this. Think about it, 1 cubed is 1. 1 to any power is 1. So that's going to undo the cube root. And 1 cubed is 1. So now I just have to solve this. If I add 20 to both sides, I get 3k equals 21. Still on the screen, yep. Divided by 3, k equals 7. Okay, piecewise functions. I'm just going to go ahead. I changed this for you guys. We made this +1 because it didn't fit on the graph. So let's get rid of that. So this is, just rewrite the whole thing, 2x plus 1. All right, for that one. So I'm going to graph the line 2x plus 1 where x is less than -2. So right here is x equals -2. And where it's less than that, I'm going to graph this thing. So this thing crosses at 1, has a slope of 2 to 1. So we all know how to graph a line. All right, but here's my cutoff. I only want to graph this thing where x is less than -2. Since it can't be equal to 2 or -2, I'm going to put an open circle there. I don't need these dots because these dots are where x is greater than -2. So I've just graphed the line y equals 2x plus 1 where x is less than -2. Now, where x is greater than -2 or equal to, I want the equation y equals 3, basically. Alright, so y is going to equal 3. That's a flat line. It's a horizontal line at 3 all the way out to positive infinity. And plugging in, when I plug in 3, 3 is greater than -2, I get 3 because I'm going to use the bottom function. When I plug in -4, that's less than -2, so I'm going to use the top equation. And -8 plus 1 is -7. You see that on the graph too. When I plug in -4,